All right, so let's take a look at a word problem. This is going to be an application of solving quadratic equations. Um, I basically made up this word problem. It doesn't really, don't take any of the facts as true, but just assume for the purposes of education that this is a true, this is a true situation that's being described here. It's about the number of piranhas in the Amazon River. All right, so it's like a population model. And it's a quadratic model, right? Meaning we use a quadratic expression to model the number of piranhas in the Amazon River. All right, and that's the equation that's given here. P equals 2x squared plus 6x plus 28. Now, x represents the number of days after the official start of mating season, as if there were really such a thing, and there's no such thing. But just assume that the official start of piranha mating season is at 12:01 a.m. on July 1st, and x represents the number of days or 24-hour periods after this time. So let's just digest what that means real quick. X is measuring time in 24-hour periods or days. We'll just call them days for short, but after a specific time, 12:01 a.m. on July 1st. So what does x equals 0 mean? Well, 0 days after 12:01 a.m. on July 1st means exactly 12:01 a.m. on July 1st, and so on, okay? So what can we take away from this? Well, if x is 1, then it's 1 day has elapsed after 12:01. So the date on x equals 1 is actually when x equals 1, the date is actually July 2nd, but it's 12:01 a.m. on July 2nd, right? So that means that 1 day has passed, right? The full, like, July 1st has totally passed, okay? So x equals 1 means July 1st has totally passed, and we're just in the first minute of July 2nd, and so on. So just if x equals, say, 5, what does that mean? That means that July 5th has totally passed, and we're on the first minute of July 6th, right? Okay, so it's important to keep that interpretation of time in mind, all right? Okay, so getting started. What is the date? So let's read the question. The question that we need to answer using this model. What is the date when the piranha population reaches 300 piranhas? Right. Okay. So when they ask what is the date, we know that we're going to somehow solve for x because x represents the number of days after the start of piranha mating season. All right. So we're going to find x and we're going to translate that into a date. That's the big picture here. So what are we going to solve in order to find x? Well, we're going to solve a quadratic equation. What quadratic equation? Well, we'll use the other given information, which is 300. So we're going to assume that the piranha population reaches 300 exactly, and we're going to plug that information into our model, right? And this is our model. So if we plug that in, that information p equals 300 into our model, right? What do we get? We get 2x squared plus 6x plus 28 equals 300. That's what that statement says. So if p equals 300, then we just write 2x squared plus 6x plus 28 equals 300. All right? Because after all, p is here, right? P is equal to 2x squared plus 6x plus 28. So if p equals 300, then I can certainly write 2x squared plus 6x plus 28 equals 300, right? All right, so how do we go about solving this equation now that we have it set up? Well, first thing I see is there's a factor of 2 on both sides. So I'm going to factor out a 2, right? From this side. And I'm going to factor out a 2 from the other side. So 150, right, times 2, right? So what's going to happen now is that these 2's are going to cancel. But first I have to write what's in the parentheses. So 2 times what is x squared? Or 2 times what is 2x squared rather? It's x squared. 2 times what is 6x? So plus 3x. And then 2 times what is 28? 14. Right. Now I'm going to cancel my 2's. Right. Effectively, I'm dividing both sides by 2 there. All right, so what am I left with? X squared plus 3x plus 14 is equal to 150. All right. Now, we need to apply the quadratic formula, but we're not ready to do that quite yet because we don't have 0 on one side. You need 0 on one side to solve most quadratic equations. So let's go ahead and do that calculation. So 150 minus 150, of course, is 0. But what about 14 minus 150? It's going to be negative 136. So I get x squared plus 3x minus 136, right? Okay, so now we're ready to go. Let's identify the a, which is 1, right? The b, which is 3, and the c, which is negative 136. All right, so it's time for the b squared minus 4ac. It's always a good idea to pre-calculate that thing. That thing, by the way, is called the discriminant. b is 3, so that's 3 squared minus 4 times a. What's a? 1. What's c? Negative 136. So that can be written as 9 plus, because negative times negative is positive, right? 4 times 136, right? 4 times 136. I don't know what that is. 136 times 4. 24, carry the 2, 12, 14, carry the 1, 5. Okay, so that's 9 plus 544, which is 553. Great. Now, according to the quadratic formula, x is negative b. What's b? 3. Plus or minus the square root of 553, right? That's the discriminant we calculated above, right? Over 2a, right? A is 1, right? So it's in the bottom you have 2 times 1, which is of course just 2. All right, so we have two answers here. We have x equals minus 3 plus the square root of 553 over 2, and then x equals minus 3 minus the square root of 553 over 2. Now I'm going to tell you one of these is wrong because, or it's not that we did anything wrong, it's just that it's an invalid answer. That can happen. All right, it's this one. That one's wrong because it's negative. If you look at it, it's minus 3 minus, something. I don't know what the square root of 553 is, but it's, sum of two negatives is negative, right? And dividing by 2 doesn't change the fact that it's negative, right? So that's a negative number. Negative numbers are not valid because the problem clearly says that x represents the number of days after the given time, the start of mating season. So a negative x would represent days before that, and it's not really reasonable to think that this model will hold before the starting of mating season, because probably before the starting of mating season it's a totally different thing going on. There's no mating going on, so the piranhas are just sort of, I don't know, just swimming around in the water or whatever. So there's no quadratic model there. All right, so the negative x's are invalid. They're not legitimate answers to this problem. So assuming this answer is not negative, which it's not, it's approximately 10 point, I can't remember, 225 or something like that. But I want to show you the graphs so we can see sort of what's going on before we interpret the answer. So I plotted the graph ahead of time so we can look at it. Okay, so here's the graph, right? Notice that, okay, here's the graph of the parabola. Okay, notice that as we get up here to this point, this point has very specific coordinates. 10.258 comma 300. So the y coordinate, or in this case we might call it the p coordinate, is 300. Okay, so when p equals 300, we get that the x coordinate is 10.258. So let's go back to the problem and put that in 10.258, right? So it's 10.25, yeah. So we have to interpret what that means. First of all, it's positive, so that's good. All right, so what if, let's think about what the date is going to be, right? If x is 10.258, what is the date going to be on this day, right? Well, as we had mentioned before, if say x were an an integer like 10, right? What would that mean? It'd mean that it's 12:01 a.m., right? On what day? On the 11th, right? On the 11th. So this time represents sometime, on the 11th of July. So that's what we write for our answer. July 11th. Right? July 11th. So I hope that's clear, right? So the integer 10 means that 10 days have passed since the beginning of mating season, and the beginning of mating season was 12:01 a.m. on July 1st, right? So that means that July 1st passed, then 2nd, all the way up to July 10th passed, right? So if July 10th has passed, then that means we're in the into July 11th. So it's sometime. We could get more specific if we work with the decimal number. We could actually compute the precise time that's predicted by this model, but we won't go that far. It's sometime early morning, seems, in July 11th. All right, so that's the answer. I hope that helps out with your homework.